Okay, so we have talked about the angles that segments create, but what about the length that segments create? I'm going to be looking at questions 15 through 18. Now, we're going to be looking at the segments, the length of the segments. 15 and 16 are going to be pretty simple, but then we're going to use that idea for 17 and 18. And let me just say that 17 and 18 will be a little more challenging. Okay, 15 and 16 are simple. Now, it says solve for x, assume the lines which appear tangent are actually tangent. But I see I have chords. Chords is a segment that goes through the center of, not through the center, goes inside the circle. That's a chord. If it happens to go through the center, that chord we happen to call diameter. Now, interesting here, looking at my chords, I'm going to look at this blue one. It's made by the segments 18 and x. Okay, let me multiply those out. I'm going to go 18 times x. And I'm going to let it equal to, then I look at another chord. I'm going to change this to red. I see it's made by the measurements 27 and 16. So I'm going to multiply those out. 27 times 16. It's going to be that simple. When we have two chords that meet inside, and I'm talking about the length of the chords, not the angles, I multiply the measurements, the two measurements that make one chord. So the blue chord was made by 18 and x. I multiply those equals the two measurements that make the other chord, 27 times 16. Okay. So on the left side, 18 times x, that's going to give me 18x. On the right side, 27 times 16, that's going to give me 432. Now, to find the value of x, because instructions are solve for x, let me divide both sides by 18. So x is equal to 432 divided by 18 happens to be 24. So x equals 24. Nice. Let's take a look at number 16. Remember I said 15 and 16 were going to be simple. So I'm looking at one chord. It's made by the measurements 10 and x. So I'm just going to go 10 times x equals. The other chord is made by the measurements 6 and 15. So I'm going to go 6 times 15. So on the left side, 10 times x, it's going to be 10x. On the right side, 6 times 15, that's 90. So let me divide both sides by 10. So x is equal to 9. So this measurement, this part right here, it is 9. On question number 15, forgot to mention, this measurement is 24. Okay, so that was not that bad. Let's take a look at 17 and 18. Gonna be a little more challenging. I see the instructions change. First of all, let me solve for x. Okay, I'm gonna look at 17 and 18 as if they were the same questions from 15 and 16. So I'm gonna treat the same idea. I see one segment. I see it's made by the measurement 2x minus 8 and 24. So I'm gonna go 2x minus 8 times 24 equals the other measurement I see it's made by 21 and 16. So the other chord, I'm gonna go 21 times 16. Because I'm starting the same idea. Okay. So on the left side, I have to go 2x times 24. So that gives me 48x. And then there's my minus. 8 times 24. That gives me 192 equals 21 times 16. That is equal to 336. Okay, so I see, let me separate my sides. I see on the left side, there's two terms, right? I cannot combine them because one of them has a letter, the other one does not. So I want this term that has the letter by itself. So I'm gonna move this minus 192. I'm gonna move it to the other side as a plus 192. Don't forget to switch the signs. So that gives me that 48x is equal to, now 336 plus 192 is 528. So let me divide both sides by 48, and I'm gonna get that x is equal to 11. So remember how when I started this question, I said, let me start it the same way 15 and 16 were. I noticed that the instructions changed, but I'm gonna start it the same way. Now let me read the instructions. Find the measure of the line segment indicated. Assume the lines which appear tangent are tangent. The instruction here it is, find the measurement as D. So it is not solve for X. It is find as D. Okay, so let me erase these things here. The segment SD is here. This segment from S to D. I know the measurement. I know something is 2x minus 8. I know this thing is 2x minus 8. However, I know the value of x now. So let me rewrite 2x minus 8, but instead of x, I'm going to write 11. So I have 2 times 11 minus 8. Like I said, I wrote 2x minus 8, but instead of x, I wrote 11 because I know the value of x. This is the reason why I had you, to begin with, solve for x. Then we went back to the instructions. The instructions were not solve for x. It's find the length of a segment, but I need the value of x. Okay, now here, I know 2 times 11 is 22. Because I had to multiply first. Now 22 minus 8 is 14. So my segment in here is 14. So I'm not asking solve for x. I'm asking for a segment. However, you need to solve for x first and then substitute it for x. The value that you get substituted for x. Okay, let's try another example. Let's take a look at number 18. Find the segment RT, but I'm just gonna solve for x to begin with. So I see one segment. Let's take a look at this one. It's made by the measurement x minus 6 and x minus 1. So I'm gonna go x minus 6 times x minus 1 equals. The other segment, the other chord is made by the measurement 6 and 6. So I'm just gonna go 6 times 6. Okay. Looking on the left side, I'm gonna go x times x. So that gives me x squared. X times a negative 1, that gives me a negative x. Then I have to distribute the negative 6. So negative 6 times x, that gives me negative 6x. And negative 6 times a negative 1 gives me a positive 6. And this is equal to 36, right? 6 times 6 gives me 36. Okay. So let me combine like terms. These two with x's, I cannot combine because they have different exponent. Okay. So the one with the x squared is just that one, x squared. Then I'm going to combine negative 1x minus 6x. So that gives me a negative 7x plus 6 equals 36. Okay, so I remember back in algebra, you guys learned back in algebra how to solve. We use factoring, how to solve when there was an x squared. The way we learned that is we move everything to one side and the other side has to equal to 0. Okay, so this positive 36, let me move it as a minus 36. So I have x squared minus 7x minus 30 is equal to 0. Remember that We did factoring. You guys did that back in Algebra 1. Now, it was easy when the first number was a 1, which it is. Remembered the diamond method. I'm looking for two numbers that multiplied is equal to -30. You see where I get the -30, multiplied. When I add my numbers is equal to -7. You see where I got the -7 from. Okay, remember that from factoring. So I'm thinking, what are the two numbers that multiplied equals -30, but when I add them is equal to -7? So first I start thinking, what are the numbers that multiplied are equal to 30? I could go 1 times 30 because in multiplication, the sign is negative. I'm going to say my numbers, the numbers that I'm thinking of have different signs. And I know when they have different signs, I have to subtract them and it's going to give me a 7. The big number will be negative, but 30 minus 1 is not 7. Okay, so that doesn't work. So I'm going to increase here my list. I'm going to increase it by 1. So my next number is 2. 2 times what equals 30? Well, 2 times 15, right? Is 15 minus 2 7? No. So that one doesn't work. So let me try a 3. 3 times what equals 30? Well, 3 times 10. Is 10 minus 3 equal to 7? Yes. Remember, I was subtracting 10 minus 3 because my signs were different. If my signs were the same, I would have added. Okay, so I know 10 minus 3 is 7. So I'm going to say the big number is 10 and the small number is positive. Now let me double check this. Is 3 times a -10 equals -30? Yes. Is 3 plus a -10 equals -7? Yes. So remember, from here, you went to factoring x plus 3, x minus 10. Remember, you went straight to parentheses. But then remember, you let each of them equal to 0. So I'm looking at the first parentheses. What's the value of x that will make this parentheses equal to 0? I know x plus 3 has to equal to 0. So here I'm going to say x must be equal to -3. I get this value. Now looking at this second parentheses, what's the value of x that will make this parentheses equal to 0? And I'm going to say, well, x is equal to 10, right? Because 10 minus 10 is 0. So I have two possible values for x. X could be -3, x could be +10. If I was to use -3 here, -3 minus 1, does that give me a positive or negative value? If I was to use -3, -3 minus 1, is that positive or negative? It's a negative value. The measurement of a side cannot be negative. So I'm going to say x minus 3 is not a good answer. Remember, I said you have two possible solutions. I didn't say you have two solutions. I said two possible solutions. -3 is not good. But how about 10? Is 10 minus 1 positive value? Yes. Here, is 10 minus 6 a positive value? Yes. Okay, good. We found out that x is equal to 10. But remember how my instructions, I go back to the instructions, it is not solve for x. It says find the measurement, the distance from R to T. Okay, so let me erase this. I see R here and I see T here, and I'm gonna have to go this and then these two. I have to add everything there. So I'm gonna add x minus 1 and x minus 6. However, I know the value of x now. Isn't this 9? Right? Because x minus 1, I know x equals 10. So isn't this 9 and isn't this 4? Because x is 10, right? 10 minus 6. So I know this is 9. I know this is 4. So I'm just basically going to say I have to go 9 plus 4 because I have to add the two segments. What's 9 plus 4? 13. Good. Notice I solved for x. I came out with 2 answers for x, but the negative is not good because segments cannot be negative. So I said, okay, x equals 10. So used it. I saw what I needed to add, and I found out that the measurement, the segment RT, from R all the way to T, that segment is 13.